Bismillahirrahmanirrahim. In this unit 2, we will derive the equation J is equal to sigma E. This equation describes how the current density J in a material is directly proportional to the applied electric field with proportionality constant sigma, which representing the material's electrical conductivity as shown in figure. It helps engineer and designer to choose appropriate materials, specifically electrical component, ensuring efficient current flow in circuit and devices. This equation also helps to classify materials into insulator, semiconductors, metals, and superconductor. We will discuss in detail in Unit 6. J is equal to sigma is a fundamental relation in electrical engineering, and that describes the behavior of the electric current in conductive materials. And where J can be defined as the electrical density, and mathematically J is equal to I over A, as we have already discussed that J is equal to I means electrical current is charge flow per unit time. A is the cross-sectional area, and electric field, which is also referred as a potential, and it can be defined in electrical engineering as a potential drop per unit length. And E is equal to minus del V over del L. And if del is very small, delta is very small, then we can approximate E is equal to approximately V over L. And similarly, electrical resistivity, which is unit is ohm centimeter or ohm meter, is the resistance offered by per unit length across per unit area. And resistivity can be defined as resistance R A over L, where conductivity is a unit in Siemens is inversely proportional to the resistivity, and we can write conductivity is equal to 1 over rho, and so rho equation become inverse for the conductivity, which is equal to the L over Ra. And therefore, when we multiply it by sigma E, sigma is equal to L over Ra, and E is equal to V over L. LL is cancelled to V over Ra, which is equal to the J. And because V over R is current, and current per unit area is equal to J. So, and J is equal to sigma E. So, in this way, we can derive the fundamental equation J is equal to sigma E.